Hello, we're going to be talking about 7.4 properties of special parallelograms. So we're going to talk about the properties of these special parallelograms or parallelograms. Anytime you see special, there's some type of pattern or something going on. Use the properties of diagonals, and we're also going to talk about how to use it in coordinate geometry. Not a whole lot on that though. We're going to be talking mostly about rhombus, rectangle, and square. So if you take a look at this really awesome chart right here, this is one of my favorites. Make that a little clear. So you have a body of quadrilaterals. These are four-sided figures. And in that body of those quadrilaterals, you have parallelograms. Parallelogram properties apply to rectangles and rhombuses or rhombi. So these are applied here and here. And the properties of rectangles and rhombus are also applied to square. So all of these properties from here on down apply. And then trapezoids and kites are our next section, and we'll do those separately. So trapezoids and kites, that's 7.5, and we'll get to that in the next lesson. So today we're going to concentrate on rectangles, rhombus, square. So take a look at the figures. A rhombus is a parallelogram. It has four equal sides. So four equal sides, so it's like a square. I like to call it a square on the edge because it kind of has a little bit of a tilt to it. Now, a rectangle is a parallelogram with four right angles. So all four right angles. And a square has both of these things. It has a rhombus where it has all four equal sides, and it has four right angles. So it has all the sides are equal plus the four right angles. And that's what makes this work right here. So a rhombus is a rhombus only if it has the four congruent sides, and if it has four congruent sides, it can be called a rhombus. So if you're given rhombus PQRS with diagonals intersecting at T, use the given information to find each measure. So if ST is equal to 13, ST is right here, find SQ. So if ST is equal to 13, and I know this is bisected, so I'm going to do 13 times 2, and that's 26. Because this is 13 and this is 13, so the whole thing is 26. Find the measurement of STR. STR in a rhombus, and I have not gone over this yet, but in a rhombus, you need to know this is perpendicular, always. So it's 90 degrees. If the measurement of PRS is 17 degrees, what is QRS? Well, if this little part here is 17, then this part is 17 because these get bisected. Something else I'm going to go over in a few minutes, but these get bisected. So this is 17, this is 17. 17 times 2 is 34 degrees. If SP, right here, is equal to 4x minus 3, and PQ is equal to 18 plus x, remember that in a rhombus, all the sides are equal. So they're equal to each other. So if I'm going to solve this, I can just say 4x minus 3 equals 18 plus x. 3x equals 21, and x equals 7. And you're good to go. So for a square, remember that it's also considered a rhombus. So a quadrilateral is a square only if it's also considered a rhombus and a rectangle. So if all the properties of a rhombus apply and all the properties of a rectangle apply, it's a square. All the sides are equal and it has those four right angles. So the diagonals of square LMNP intersect at K. Given that MK is 1/2, find the indicated measure. Well, this is 1/2 from here to here. So what is the measurement from here to here? It's 1/2. So the measurement of PKN, remember I said that these all intersect on a rhombus at 90 degrees. That's true of a square as well. So 90 degrees. And MNK, this is bisected. So this is 45 and this is 45. So 45 for that little angle right there. Okay, so the diagonals of a rhombus intersect at E. So here's their intersection. It gives you the measurements of 44, 7, and 9 here and here and here. And find the indicated measures. So BC right here. In a rhombus, remember that all sides are equal. So that means BC is 9. And AC, well, if this is 7, and then this is 7, then the whole thing is 14. And the measurement of ADC takes an extra couple steps here. ADC is the angle that we're looking for. And remember that this is 44 and this is 44, which makes the whole thing 88. Subtract that from 180, and you get this as 92. Okay. So the diagonals of rectangle. EFGH intersect at I. I is a terrible variable, by the way. Try not to use that in the future. Given that the measurement of HFG is 31 and EG is 17, EG, this whole diagonal right here, is 17. Find the indicated measure. So the measurement of FHG. So FHG. Well, if this is 31 and these are parallel, then by alternate interior angles, this is also 31. And remember that the corner of a rectangle is always 90 degrees. So 90 minus 31 is 59 degrees. HF, this right here, in a rectangle, remember the diagonals are exactly equal. If not, you'd have a crooked television. So that's also 17. And EFH, this angle right here, is the same as the one we found here, which is 59. So this is also 59. Okay. Some of the things you need to know are also on your paper. Things that I've talked about already, but not really. So rhombuses are diagonal at a perpendicular. The perpendiculars or the diagonals will actually bisect the pair of opposite angles. So these are equal here and here and here, and then here and 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 here. They're equal to each other. I kind of went over that in the example. And the diagonals theorem, for the rectangles, the diagonals are exactly congruent. And a rectangle has to have 4 right angles. We talked about that. So let's practice some of this. This is a little bit of a longer lesson, but let's get through some examples so you can see what we're doing here. So find the measures of numbered angles in the rhombus ABCD. What is the measurement of ADC? So ADC, this whole thing is what I want to know. And BCD, this whole thing I want to know. So I know they're not equal to each other. I'm going to put 2 marks there. But I do know that this is 61 degrees. So therefore, this has to be 61 degrees. And the whole angle here is 61 plus 61, or 122 degrees. I know that this angle here and this angle here are supplements. So 180 minus 122 will give me 58. And so I know that that's 58 degrees, and you're good to go there. So this whole angle is 58. That means that half of that angle is Do I need to know that? Yeah, I do actually. Half of that angle is 29 degrees because of angle 4 right here. I'll need to know that. So half the angle, half of 58 is 29. And now I can just go over here and fill in a bunch of measurements. So I have angle 1, the center of any rhombus or square, 90 degrees. Measurement of angle 2. If these are 61, these are both 61 as well. Opposite angles are congruent and bisected by the diagonal in a rhombus. So 61, 61, 61, 61. So there's my other two answers. Angle 4, I already figured out the measurement was 29. ADC, ADC, I figured out that was 58. And BCD, I figured out that was 122. And you're good to go. I know that's a little bit confusing. The more you do it, the better you get at it. Just remember that these are bisected by those diagonals. The center is always 90, and that these opposite or consecutive angles here, not opposite, but consecutive angles will add up to 180. So opposite or congruent, consecutive are supplements. So take a look at this one. Find the measures of the numbered angles. So basically what you need to realize here is they're all going to be exactly the same. 118 from 180 is 62, which makes this whole angle here 62, and this whole angle here 62. So divide that by 2, and you get all of the angles equal to 31 degrees. Okay, in this rectangle, find the lengths of the diagonals. So remember, the diagonals in a rectangle are congruent, otherwise you'd have crooked television, and you'd probably end up with a headache from watching it like that. So when you solve here for x, you are going to get x is equal to 23. It says find the length of the diagonal. So if I plug it back in to either one, it doesn't matter which. Minus 15, it's going to equal 77. So that means the length of either diagonal is 77. Same thing for this. Length of diagonal, again, they're equal to each other. So you get x equals to 14 when you rock your boat and solve that. And plug it back in. Either one, it doesn't matter. And you get 39. So the length of the diagonal is 39. Okay. I believe that's right, because 2 times 14 is 28, plus 11 is 39. Yeah, that doesn't seem right, though. So let me double check my work here. You get 3, you get 14. Oh, this is 31, that's why. That's why it didn't look right to me. It's 31. I just didn't write it. Okay, so 5x minus 31. So now that makes more sense to me. Okay, so given the square with the diagonals intersecting at O, use the given information to find each measure. So if xy is equal to 5, if this were to equal 5, then wz is equal to 5. Not so bad, right? Because if this is 5, then this is 5. And it's a square, so don't forget we're using square properties here. If wyz right here is equal to 7y plus 3, but remember that those angles in a square are bisected. 90 degrees once you bisect it is 45. So if you go to solve that, you will get y equals 6. And xw, right here, if this was 2x plus 1, and yz, right opposite side, right? These two opposite sides, find x. Well, in the square, all the sides are congruent. So 2x plus 1 equals 4x minus 7. So once you get done solving for that, you get x equals to 4. And yz, this side here, and wz in a square, remember they're all equal. So these two sides are equal right here. So 3x equals 5x minus 4. And in this case, x equals 2. And the last one, same type of principle here. This side right here is equal to this side right here. So these two sides are equal because this is given as a square. So 5y plus 1 equals 2y plus 4. And in this case, y equals 1. So there are your answers. Go ahead and check your work as you're doing these. I really suggest, if you kind of have a handle on this, to try it ahead of time just to see if you can actually get this and you understand the concepts. Complete each statement. So DG is congruent to EF. DE is congruent to GF. GH is congruent, to HE. Angle DEF is congruent to DGF. And EFG is a supplement of DEF, or you could say DGF. Remember, they're congruent, so it could be either one. And triangle DEG is congruent to FGE. So take a little bit longer to look at that if you need to. Pause the video, and then you can figure out how I got those answers. Last couple of examples here. Solve for x. So remember that these would be equal to each other. So 2x plus 4 equals 3x minus 5. Solve for x, you're going to get 9. You plug that back in, and you're going to get BC equals 22 because you're plugging it in to either one. It doesn't matter. Solve for x on this one. Now, this diagonal is equal to this diagonal because it's a square. So they're equal to each other. So it's still going to do 3x equals 2x plus 15. And in this case, x is going to equal 15. Plug it back in, and x equals 45. Now these next few, if you need more examples, pretty similar. But remember that this is equal to 90 degrees. So this is going to be 4x plus 5 plus 5x minus 14 equals 90. Because that corner right there is 90 degrees. They're not 45 and 45, it's just 90 for the whole thing. So you end up with 9x minus 9 equals 90. And then when you get done solving, x equals 11. You plug that in and you get 41 for that angle. Okay, just a couple more. So solve for x. Again, these are going to be congruent to each other. This is a rectangle. So solve for x, plug it back in. And when I plug this back in, I get 2x plus 3 equals x plus 12. X is going to equal 5. Plug that back in, and you're going to get 12 minus 5, which is 7. 7 plus 7, because you're looking for MO, you're looking for this whole piece right here. So 13, 7, something's not right here, minus, plus, nope, I made a mistake right there. It's supposed to be a 1, 5, 15, sorry. So 12 minus 15, no, you can't have that, because 2x plus 3. So minus, oh no, sorry. I'm really losing it here, guys, and you're not even here to like correct me. Makes me sad. So x is equal to 9, so it's equal to 3. So the whole thing, nope, that still doesn't work. So, because that would be 18 minus 3, which would be 15. 18 plus 3. So, am I not reading this right? Oh, it's minus x, that's why. So I'm going to add it, get 3, subtract it, so 3x, x equals 3. Okay, that's better. That's much better. So I get 12 minus 3. 12 minus 3 is 9 times 2, 18. Okay. I wish you guys were here to correct me on these things when I go brain loopy. All right. So this one. You have a little bit of a different situation here because I have the whole thing here and I only have a part of it here. So I want to solve for x. Well, the whole thing is equal to 2 times the part of it that we know. So by the time you get done solving, you get x equals 35, and you plug it back in, you should have 40. But remember that this whole thing, that's half of it right there. So if I want the whole thing equal to the whole thing, I need to multiply that by 2. Or I could divide this by 2, but multiplying is a little easier sometimes. And like I said, I'm going to skip these 2 examples, but I can show them to you real quick, just so that you have them if you want them, but I'm going to actually skip them. So you have a parallelogram rhombus, and you have a parallelogram rhombus rectangle square. So those are the last 2 examples on this. Sorry about the brain flub on the other, but you guys know me, so you know it's bound to happen sooner or later. Sorry again for this being such a long video as well. Hopefully you stuck with it, got some examples, have an understanding of rhombus, rectangles, and squares. Talk to you guys later.